All right, so we are biopsychosocial systems. What does that mean? It means we're part just all physiological, right? All the things that shape us, automatic heart beating, breathing, muscles, tissue, bones, etc. Then we have our psychological part, which is just the mind itself and how it processes information, and then we're social too, right? We shape ourselves based on our interactions with other people, things, other animals, etc., etc. So understanding this gives you insight into behavior, which requires studies of interactions between biological, psychological, and social. So basically, an integration of all three is kind of how we analyze to assess what's happening with you or anyone else, with a person. Right? Integrating all three, biological, the psychological, and the societal part. Biological psychologists use advanced technology to study these links, right? They use all types of scanners, electroencephalographs, things like that, and other tools. And neuroplasticity makes the brain, human brain, unique. What does neuroplasticity mean? What do we think it means? Anybody got an idea?
Like the makeup of the brain systems.
Yeah, what about it? What about the makeup of it?
Like everybody's is different. Or like the neural links and like that.
Yeah, I mean, everybody's is different, right? We're all different, but it changes, right? So when you learn something new, your brain, the systems change, right? If you have some sort of trauma or head trauma or something, your brain will change too. It doesn't even have to be in the brain, it can be in other parts of the body. Right? So your brain is constantly changing. Think of this, you guys are like what, 18, 19 years old? Who here is 20 or 21? Okay, one person. So the front of our brain, the prefrontal cortex, right? Which is the last part of evolution, right? Because it means that humans tend to have the largest of this compared to all the other animals, right? Which gives us the ability to make all the stuff we have around that other animals don't do. Think of that. That typically doesn't stop maturing or growing, typically. So you're about like 27, right? Think of that. You can be 21 and old enough to drink, and the law says this and the law says that. But just from a developmental point of view, you may not be fully matured mentally until you're like 27 years old. So you can ask yourself all these questions. Hey, why do I do that? Why did I feel this way? Man, I was stupid. Yada, 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 right? But there's some real science behind it. But even past that, your brain will change forever, right? It's not just gonna stop at 27. You're still gonna have plasticity based on what you're doing with it, whether you're learning, not learning, engaging in activities, et cetera, et cetera. So biology and experience interact to facilitate new pathways as the brain changes and adapts to a changing world. If you go into a new environment, that could alter your brain. You go travel around the world, you might have a new perspective. That new perspective alters your brain chemistry. It changes a lot about you. In essence, why people say like, yeah, I'm a new person. You know, I've changed. It's a real thing. All right, some terms to learn. And these are big ones. If you can understand just this stuff, you kind of get the real circuitry or the real basis of how this all works, right? And this stuff is not that complicated to understand. I'll try to make it as simple as possible, right? So we got our neuron, we got our cell body, we got our dendrite, our axon, our myelin sheath, our glial cells, our action potential. All right, so neuron. This is the big one, right? So every cell in your body has a cell body, right? That cell body contains your DNA, your genetic information, your RNA, all these different things, right? So here we say, hey, here's the cell body right here for what we would call a neuron. Located right here. Now outside the cell body, how does information get in here? Right? This is the part that's gonna decode all the information. It's gonna process everything. But how does new information get in? It gets into these things, which looks like branches. These are called dendrites. So these branches right here receives messages from other cells. So if you want to think of it simply, you're thinking of your brain almost like a computer, right? Like it takes stuff to be processed. You have to input information in order to get an output of something, right? Inputs, outputs. So you're receiving information through your dendrites, right? Passes through the cell body, and this is your life support, right? This is all the stuff that keeps you alive. Typically, if you die, that means your cells replicated enough to where they can't replicate anymore. Now you have a natural death, right? Your cells can only replicate so many times. Okay, and here we have what would be like a highway system. So think of it almost like an electrical cord, right? Great, man, we need a cord to hook up to a power outlet in order to turn the light on, turn this on, etc., right? But this highway system is called an axon, right? So all the processing of information, it goes down this highway system, and it passages messages away from the cell body to other neurons, muscles, and glands. And here we have the coding on it. So think of almost like the coding on a wire, right? What's the point of wires being coded, right? Like you got a cord, why is it coded? Well, it's just not an actual copper wire or something like that. Yeah, what would happen if you didn't have the wire? What are some of the things that could happen?
The message could be lost.
Yeah, like it could, the electrical impulse could disperse, and you would lose the actual true electrical impulse that's needed to go into whatever circuitry you're trying to get into, right? So it could be lost, something else could touch it, like you touch an electrical wire and it's exposed, you'll get shocked, right? Other things can be affected. It has to be coded. So this is fascinating thing. You're like, well, and it's really actually does looks like a wire, right? Like, hey, most things that we've created, I guess, are based on some sort of biology or observation of nature. So you do have this myelin sheath. And that myelin sheath, it can be damaged too, in which case you can have a lot of issues in this damage, right? A lot of mental issues or other bodily issues. You even have like things like diabetes and things like that. All right, and here at the end you have terminal branches of axon. Right, here's your terminal branches. This is basically information coming in, going down this highway system, and gets pushed out. But this is going to push out to other cells, right, to other neurons, or to other parts of the body for a specific task. Right, and this myelin sheath here also helps the speed of neural impulses. So this has affected the speed in which you say like, hey, motor functions, I can't move as fast as I used to, right? There may be some damage to some of your myelin sheath because the reaction of those electrical impulses are damaged. Now think about this. This is electric. The stuff going through here is in your brain is electric, right? And also what? Electrical and what else? What else is in there? Yeah.
Chemical.
Yes, right? Electrochemical processes. So you got electricity and chemistry happening. There's a lot of chemistry here. There's mostly electricity here. A lot of electricity here. Right? But there's some chemicals mixed in too. So how does it all work? How does it all start? It has to come from somewhere, right? And we would call that an impulse, an action potential. So a big word is action potential, right? So really you could call it an impulse. So it creates, think of it this way. Your body, through all its systems, without any stimulus, nothing, is at rest, right? And that rest you could call like maybe homeostasis. You're like, oh man, I'm in balance. Everything's balanced. Now, anything that causes a stimulus causes an action potential. It'll cause an electrical reaction. Something is happening for electricity to come here, jolt out, and work with these chemicals that be here to jump out and go to another mind, to do something. What are some of those impulses? Think of something.
Telling a muscle to like move or something.
Yeah, think of it. I mean, literally anything. So if you're asleep, right, or you maybe not in deep sleep, because there's phases of sleep, right? But you're not completely in deep sleep, and you hear like the smallest, faintest sound in your house, right? You're ready to like jump up and wake up, right? That means your brain automatically, an action potential happens. Something is not flatline, something's above what we call threshold. Right, so your threshold is your bare minimum, it's your homeostasis, it's your balance, and all through your body, your eyes, your ears, your nose, your legs, all this stuff. And if anything is stimulated, right, you hear a small faint sound, your brain kicks in, something's happening, right? And then that information jolts. And now it says, okay, we gotta do something. What was that? My eyes open up, right? I may sit up, I may wanna listen again, I furrow brow, all the stuff that takes place. And if you recognizing that something is different, something is above threshold, what we would call it, right? Now this works in different degrees. So say you're at a party, and you're like, man, it's super loud, or you're at a nightclub or wherever, and it's super loud. Now your threshold is different, because there's a ton of noise, right? And then you might hear something real unique noise. You're like, what was that? It's super loud. Now you have a new action potential. So your threshold may change depending on the environment. If it's loud, you still can hear something different, unique, right? Therefore, your brain will be alert, send electricity down, mix in with chemicals. Okay, let's figure out what's happening. Let's figure out what that was. Or let's figure out what I just saw. So it doesn't just work from hearing, it works from all types of things. Temperature, it's cold, right? How do you know it's cold?
Your body will start to shiver. Your body will start to shiver.
Yeah, so something's happening. There's some receiving cells, receiving information down at that. Hey, this is different. We were just fine at a comfortable temperature. The temperature's no longer comfortable, no longer homeostasis or balance, whatever you want to call it. Something, we gotta do something. Put a coat on, it's too hot, take some clothes off, it doesn't matter. But we want to get back to the homeostasis. So think of that. Our life's kind of purpose as human beings is almost to always move towards comfort. Always. And when you're out of discomfort, we can call that stress or anxiety. Right? You show up to an 8 a.m. class that nobody wants to show up this early to go to school and learn, right? Barely woke, maybe didn't have your coffee. Could be stressful, could be anxiety, right? Right, hey, what am I gonna do to pass the time? I'll bite my fingernails, look at the computer, I'll do this. These are just natural reactions. Just natural human reactions to come back, to get back to comfort, right? We fidget, we click our pens, do this, do that, yawn, whatever we gotta do. And half the time you're not even thinking about what you're doing, you're just doing it. That's why you don't try to control every little detail of everything you do. But your body is this automatic machine. And it's like, okay, this is uncomfortable. This is kind of stressful. It's kind of boring. Boredom is an anxiety, right? Depression is an anxiety. Too much happiness is an anxiety. All of this anxiety just means it's not in a balance. Too little of it, bad. Too much, bad too. That makes sense? Any questions? So yeah, think of that action potential as just that signal of electricity just jumping and saying, okay, something's different. Boom, we need to figure out. Now, as we learn in the next slide, So here they're just reviewing, right? And firing electrical changes down the axon with stimulator. That's the action potential. Electricity is generated from chemical events, ions, charged atoms are exchanged. All types of chemicals are happening to make that electrical impulse happen, right? The different compounds of chemicals in your body, sodium, all these different things. Inhibitory versus excitatory signals. What that means basically is your brain these neurons don't have an in-between. There's no scale from 1 to 10, there's no scale from 1 to 5, there's no how strong. Literally, the signals work on open, close, just like an electrical circuit. Works like a computer. It's either 0 or 1s. That's it. It's either on or off. That's it. There's no in between. Inhibitory versus excitatory. Do we need something to happen, or do we need something not to happen? Right? Does the information jolted from that action potential say, hey, let's shut something down? Or says, hey, let's make something happen. Let's do something. Or says, no, let's not do something. Right? Let's excite something or not excite something. We talk about that threshold. That's basically the balance, that homeostasis, right? That normalcy, that comfort that you want to be in. There's a refractory period, which means that sometimes there's a waiting period in there, right? Depending on what's happening. And all or none, zeros or ones. There are no ifs, ands, or buts in between. It's either on or off. All right, so this one is just talking about neurosimulation causes a brief change in electrical charge. What we said, we've got these molecules in your body. Here's sodium ion, potassium ions, right? All of these molecules create electrical charge in the membrane. So also you have neurotransmitters. So think of this, that part where it comes out in the axon, right? That has to jump and go to another neuron. They don't touch. They physically do not touch, right? You're like, how the heck does that work? How do they don't touch, but it's still gonna shoot information to the next one to do something, right? And we'll call that synapses. Anybody ever heard of a synapse?
Yeah.
All right, so you call that synapses, or the synaptic gap, they'll call it. It's a gap. And basically that electricity and those chemicals are sent to down the axon. Let's see if we can go back and show you. Down the axon to the terminal branches. So here, output of information coming out. There's a gap here before it goes back to the next one of these. Here, there's kind of like on the inside, there's little bubbles. These bubbles, when they get hit with the electrical charge, the bubbles burst. And they essentially burst, and they burst out into sending chemical signals into the next neuron. Yes?
So the dendrites never touch them? Or
No.
the terminal branches never touch?
Terminal branches never touch the dendrites of the next one. And that's what we call synapses, which is fascinating. You're like, man, that's kind of crazy. Like, why would it not touch? Like, what's that design all about? Or just be a big gap and send information to. And those are what we call the chemicals that jump that hurdle, right, up the synaptic gap. We call those neurotransmitters, right? So they influence your emotions, your emotion, acetylcholine that plays parts of memory. So people with Alzheimer's, they may have too little of that chemical or neurotransmitter, right? Thus, they may be given some medication to bring it up so it can kind of create some sort of equilibrium. Think of when you're taking any medication, right? Doctor prescribed you some medication. Is it because something's happened of too little or too much? Right? Something is too much or too little. Therefore, we gotta give some sort of chemical compound or prescription of medication to try to either, substitute to create more, to make up for those differences. And the messengers between motor neurons and skeletal neurons. Think of that, like those neurons, they're not short. They could be, they're part of your central nervous system, so they go to your muscles. They don't just hang out in the brain. They stretch out, they go to your muscles, they go to your limbs. They say, hey, move arm, move leg, move foot, right? It has to send those information very, very quickly. Very, very quickly. And then we got endorphins. Endorphins, similar to naturally occurring opiates produced in the brain, they kind of stop pain, right? So if you were to experience any kind of really, really bad pain, your endorphins will kick in. So in some situations, your body is still trying to comfort itself. So think of people in war. There's people who could get injured, right? There's an explosion that happens, right? An explosion happens, and now you're laying on the ground, and you don't really feel anything, right? And endorphins kick in. You look down, and your leg is blown off. It's gone. Now that you finally looked, your brain actually visually looked, now you're gonna pass out and freak out. Before you looked at it, the body did what it was supposed to do. It's like, hey, we're trying to move towards comfort again, right? Kicked in and helped with the pain. But now that you visually looked at it, you're gonna scream and freak out. And then your brain is processing like, what the heck? This doesn't make sense. That's what's processing. So it just goes to show like our mind and body situation, is definitely two separate things are happening, maybe even more. And we said, with a lot of automated processes that you don't think about, you don't make it happen. Not your critical thinking, not your consciousness and awareness, right? We all share these bodies that do what it's supposed to do to survive, first and foremost. And the extra part is just that part of the brain that we're aware of everything, right? Drugs and other chemicals alter neurotransmission, right? Agonist molecules increase neurotransmitter action, so drugs can either increase the actions. Antagonist molecules decrease neurotransmitter actions. Uppers and downers, you take some cocaine, right? Your adrenaline rushes, your heart beats fast. You've increased a lot of action in those neurotransmitters. Your brain is sending big signals, really, really fast. Downers, maybe you smoke some weed or whatever, and then you're in chill mode. You're not, you've decreased neurotransmitter action. You're more relaxed, probably below your threshold. So yeah, the drugs just basically alter the neurotransmitter functions by changing either for or against, increase or decrease. So how do they communicate? Remember we say here, okay, it comes in, information comes in, it goes to the neuron, goes down here to myelin sheath with the action potential. And here we see, you can't really see the gap, but there's a gap and they show it here, right? So here the terminal branches hit another receiving neuron, just like this one. But if you look closely, you can see that there's a tiny gap. They don't actually touch. They're real close. They actually touch. And here are your transmitters. So we say these little bubbles right here, they burst, and then they send the chemicals, electrochemicals, out over here. And the next So they bind, the molecules cross the synaptic gap to bind receptor sites onto the receiving neuron. This allows electrically charged atoms to enter the receiving neuron and excite or inhibit new action potential. And excess neurotransmitters are reabsorbed, a process called reuptake, drift away, or are broken down by enzymes. So basically, you may not need all of these neurotransmitters, right? You may not need all to get whatever you needed to convey to the rest of your body. So what happens to the extra ones is what they call reuptake. It either goes back in, chills out, and wait for the next signal to come, right? Chills out, or it drifts away, comes out and just dissipates into the body, or they're just broken down and eliminated by enzymes. So the process is pretty efficient. Takes care of all the waste. Make sure that just enough amount gets over here into the receiving neuron to do what it's supposed to do. All right, who here is taking this a basic physiology, anatomy course? We're aware of kind of basic biology. All right, so your nervous system. Chemical communication network consisting of all nerve cells in the peripheral and central nervous system. All right, so here's your nervous system. Central nervous system is your brain and your spinal cord. All right, and here your peripheral nervous system. We see it kind of, that's a big one because all the things sort of in right there on this side. So you got your peripheral. All right, these are autonomic, which is self-regulating actions, internal organs and glands, right? Things that make you sweat automatically, self-regulating blood sugar level, right? And then from there you have your sympathetic, arousing nervous system and your parasympathetic, calming nervous system, which really a lot of people identify these as like fight or flight. Right, you're thinking if you see something that makes you dangerous, these kick in. Okay? Fight or flight. And from here you have your somatic nervous system, which creates sensory input. Right, so these are basically all of your senses. And motor output controls skeletal muscles. So here is basically eyes, nose, ears, mouth, hands, anything dealing with your senses is coming from somatic. And that also addresses your physical movement, body movement, motor skills. So it all works. We also, taking in all this information from the world and the body's tissues to make decisions and send information back in orders to the body's tissues. Your body's constantly scanning the environment. You can say like, hey, we feel cold or hot. The light's too bright, it's too dim. Sound is too loud, it's too low. We're constantly examining our environment automatically to send some information about what to do, right? What to do next. So we just kind of discussed these three sensory neuron types. One controls senses, other one is movement, and then your interneurons, which controls everything else. All right, so here, central nervous system, brain, spinal cord. From here, messages sent out, heart rate, acceleration, pupil dilation, digestion, glucose, reproductive organs, and then your parasympathetic. So these are all sympathetic nervous systems about arousing everything, right? Heartbeat acceleration, stomach, increased glucose, and over here is calming, slowing your heartbeat, simulating digestion. Basically, to keep it simple, they're both working their own way to try to regulate. So one either kicks in, the other one kicks in based on what's happening, right? You have receptor cells all over your body. So you got skin receptor cells, in your fingertips, how you feel things that are hot or quickly. You have your motor receptor cells, getting information from your brain about movement. Hormones, adrenal glands, epinephrine, neuroepinephrine, pituitary glands. Here are some of the glands they have here. Hypothalamus controlling pituitary gland. Pituitary gland controls sort of growth. All right, so think of people who have large pituitary glands. They grow to be 7, 8 feet tall. All right, and they secrete many different hormones which affects other parts of the body. Parathyroids, if you know people with thyroid issues, right, affects metabolism, how they break down foods. Parathyroids help regulate the calcium in the blood. Pancreas regulates the level of sugar in the blood sugar levels. And adrenal glands is a fight or flight response. That's the direct one. That's why essentially people say like, when you feel something in your gut, that's wrong, right? Like, man, something feels off, I felt it in my gut. Well, you felt it down here in your adrenal glands. And ovaries, so female reproduction and male reproduction. So think of things like, easy one, like dopamine. What is dopamine for? Yeah.
The thing that like makes you happy, or like sends messages like keeps you going normal,
Yeah. So dopamine is like your reward. Yes.
Is it like more like anticipation of pleasure, or is that off base?
No, it's both. It's actually both, right? It's the pleasure. So, which creates an anticipation, right? Because you have to experience it to anticipate what it'll be like the next time. It's a reward center, right? Hey, you feel great because you got an A, right? Motivates you to do what? Well, go get another A in your next class. Motivates you to get up, right? You score 30 points in basketball games. It's gonna motivate you to work out even harder and practice to go get even more than that, right? You get some sort of reward. You go on Instagram, you get 1 million likes off your post. You feel rewarded. Now you're motivated to become a social influencer. You go, So it's your reward-based center. It's the things that makes you feel like you've been rewarded. And in essence, they've done tests on primates, so like monkeys, apes, things like that. And the testing done from that really shows that, and put it in simple words, the road to the destination creates higher dopamine than the actual destination. So if you're going on a trip, the actual excitement about planning, thinking about it, all this different stuff, talking about it, you have more reward happening in your brain, measured, they've measured this, than when you actually go and when you actually show up, right? So it does show like it does create this thing to make you want to keep doing something, which can also be addictive, right? So they say, hey, dopamine, I'm addicted to a rush. I'm addicted to a high, I'm addicted to whatever, extreme sports, something like that. So really, yes, the anticipation of it is the big, big part, the part that's kind of overlooked, as opposed to just the actual final thing you do. So then you apply that in you guys' life, and like in whatever, in high school or even now, like what are some things you may do and you're like, man, that's awesome, that felt great. And then after you do it, you're like, man, I shouldn't have done that, right? Hindsight is 20/20. But the fact that you get that motivation about doing it, it just triggered all this in your brain. You probably couldn't stop yourself, right? So a good balance means you'll make good healthy decisions. So too much dopamine means you might make very poor decisions that later on you may regret. Or vice versa, or this may be great stuff. Who knows? Any questions so far?
In the adrenal glands, which one is the fight or the flight? Like, is epinephrine fight or flight, or more epinephrine?
And so the epinephrine would be more, I would say more fight, or norepinephrine would be more non-fight, right? Or flight. Questions? Does this make sense? Yes.
Isn't like dopamine like the main source of like, I'm sorry if you said this, but like, isn't dopamine like the main source of like why we like do drugs, or like why people continue to do drugs?
Yeah.
Like,
Yeah, man, think of anything you do that feels good. Literally anything, right? Your habits, just say your habits. Whatever you do, we all do different stuff. The same goes with coffee. Gotta have my morning coffee. Like, just because the DEA or somebody didn't say it wasn't a drug, doesn't mean it's a drug. We just classified all this as drug. Anything that affects hormones, chemical, electrical things happen in your body, right? So me with my coffee in the morning, I want a reward. I gotta have it. It's like the equivalent of somebody on cocaine. Maybe somebody who gotta have whatever drink they get from Starbucks, Dunkin' Donuts. I gotta have it. I go get my Frappuccino. Why? Because we know it makes us feel good, and that's a reward. And guess what? We do it over and over and over again. The same simple concept could be applied to any drug abuser, substance abuser, right? It's just they are doing something that may have a little bit more addictive factors to it. And then second, their genetics may mean like, hey, they're more sensitive to that thing, right? Maybe their mom or dad was also alcoholic or something like that. So you're probably like, man, if I potentially have those same genes, that information inside of me, if I do that particular thing, mom was alcoholic or dad, and I start doing it, I may be at a higher risk than somebody else who started doing it, right? But yeah, anything that gives you pleasure, rewards it. Think if you get your phones and your laptops taken away and the internet for 3 months, would you be miserable? What do you guys think you would do? How would you behave?
I wouldn't do anything.
You wouldn't do anything? So you need it.
If I'm bored, like I gotta go on my phone. I'm bored.
Yeah, you gotta, because you're bored. Remember we said anything too much or too little is stress. And we are all constantly trying to move toward homeostasis and comfort. Right? So you're kind of like, I'm bored. But then you think like, okay, I'm bored, I could do anything. Right? Go for a walk. But you guys are more sensitive to it than me. Right? Because I wasn't born in it. I was, born when it was happening, So for you guys, think of just that concept. You're more sensitive to being connected as opposed to someone older, generational gap, right? Someone, your grandpa or whoever, they're like, I don't need it. It's cool, it's useful. I use it for what I need. You're like, Grandpa, how come you only use it for 3 things? You only shoot email, and then you guys back, I do 1,000 apps and I do crazy stuff. Right? Just like with our genetics, we're just like, hey, one person wasn't in the same environment as us, therefore the way that they are sensitive to the thing is not the same, right? So we took away from you, you might have, you might, I don't know what to do with myself, what the heck, right? Took away from an old person, like, who cares? Go for a while, get it back on its own. The same happens with our body, right? Same application applies. We're just more susceptible. And who knows what the future looks like, right? When AI really takes over or whatever, how that's gonna look. Yeah, and hormones, right? What time is it? 41?
It's 41.
Glands and hormones, right? We're 12, 13, innocent little adolescents, and then you hit puberty. Now your body and nature is like, man, we're gonna throw everything off for the sake of now you can reproduce, right? You have hormone change. your acne, right? Your voice change. For men, you know, their voice gets deeper. Kids all have all type of changes within your body, right? Females begin a cycle, right? Men may become more sexually, aware and want to pursue different things. So nature does what it do and says, here's some action potential, here's some reward centers to do something. Why? So we can keep the species going, plain and simple, right? And then you also live in an environment like, wait. You know, the law says this, the law says that. I'm broke, I don't have a job, I don't have any money, like, can't be doing all this stuff and having children. So your external environment kicks in too and like, wait, let's balance this. Can't just be what nature only wants, because we live in an environment which we've created with different rules and systems and stuff. So therefore we start to make rational, logical decisions. It's like, let me do some other stuff before I just let my hormones take over me, right? But they're still there. We're kind of not even beyond puberty, we're changes in hormones. As you get older, your body chemistry changes. Women stop having a cycle at certain ages, and they'll have like hot flashes, and they'll have mood changes. Guys have experienced a lot of stress. Mood will change, right? You become angry and bitter, depressed, based on whatever happened in your life, right? Maybe you worked too much, you didn't end up being what you wanted to be, life wasn't enough to think it is, or you're abusing some sort of substance or something. Anyway, it's a feedback system, right? It all happens, it goes back and forth, and we're still trying to get back to the center. So yeah, keep that in mind. Life is best lived in the center. Two extremes are never good. This kind of applies universally. Let me see what else here. All right. Maybe we'll stop right there. Okay, question. Well, you guys gotta have some questions about something. What to do with the field of psychology, career advice, college advice, Concordia, what are we thinking? Who here is satisfied with their college experience so far? Is it what you thought it would be?
No, exactly.
Who said no? Why?
In high school, they made it seem scarier than it really is.
Oh, they made it seem scarier. What's your thought?
In high school, it made college seem like, I don't know, like it was, like you just on your own.
Yeah. So apply that to kind of life itself, right? You got what other people tell you, and now they've instilled fear onto you without a real experience, right? The truth of the matter is you don't know until you showed up, right? So that's like life. But basically it's like, even when we're working with this stuff, you do have a choice. You can accept or reject, and we say on or off. Okay? What you're telling me, I either accept it now, I have fear, right? Fear of something I don't even know, which is not, think about that, it's crazy, like, or you like, I'm gonna shelve it off somewhere, I don't have a fear. I don't have an opinion of it neither until I experience it, right? Now I have an opinion. Because we say fear, why bother myself with these anxieties from other people when I never experienced? It's like asking somebody, it's like asking somebody who's broke how to make $1 million. Right? Yeah, you make $1 million, right? They're broke. So that the point is to like keep the sort of balance even with your environment, what people tell you, what people trying to promote on you, trying to steal you. You don't really take it for anything until you experience it. There's the real information, right? Your brain will kind of do what it needs to do to make sense of the world. Who else? Who else said college is not what they expected. Why?
I mean, after my first semester, then I realized just how bad impressions.
Why is it bad?
Don't prepare you for like what college really is. It's more like taking like these psychology courses and realize what a student needs. And it seems like schools are doing the exact opposite, even though they have the information needed.
Yeah, I mean, in my opinion, bless you, my opinion, school is way too long. I don't think anybody should want 12 years of school. I've been in school a long time, right?
Plus another 4.
Yeah, and even beyond that, right? Because it's like you're learning stuff that your brain, even this stuff, it doesn't matter what class you take, your brain is only gonna absorb
So much.
less than 10. Lucky 3. I'll be honest. Like if I ask you about some random classes you took, you're like, I don't remember nothing from that class. Why? You didn't have action potential. You did not have an interest. Therefore, your brain and your body is like, this is boring. I'm not storing this in my memory. Forget what this dude's talking about. It's not important to me, right? And then you take pleasure. Oh wow, sit in the front row, right? And thus, it's a lot of waste. So you think about it, you do waste a lot of time when you could be doing something else, right? Especially when we do have the internet, so we can look up and learn if we want to. We're, motivated to do that in a different way. Yes, but here's a short part, like getting your bachelor's, right? So I went and got a bachelor's, have a master's. I went to a little bit of law school, and I want to be a lawyer, and I got a PhD. So just a lot of school. But in essence, they say bachelor's is to get a job, right? Master's is to teach people. PhD is to teach yourself. So the point is, like at a certain point, like you don't need a PhD. Well, the point of getting to a certain part or time in your life, eventually you'll be able to teach yourself instead of just regurgitating what everybody else in the world is telling you, right? And we're not there yet, so just use this opportunity to do your best and let's say figure out what you really, really want to do and don't waver from that. Because today you be like, I got a job making $40,000 and it's something I hate, like you really are wasting your time too. The end result is really, really bad. Anything else before we go? What time is it? All right. Anything else? Other questions? All right. Well, no class Monday, right? Thank goodness.